Hi and Assalamualaikum everyone. I am Humaira. We are from Group 8 and in this video we're going to explain about various topics that are related with amplitude modulation, angle modulation and radio digital modulation topics. This is our team members, which is the first one is NURHUMAIRA AISYAH, which is me, MAHALEXMI, BARRANI, SITHA, SANKER and HAZIQ. Alright, without further ado, I'll explain about a common transmission line which is time division multiplexing, or people call it as TDM. It is a technique used to transmit multiple signals simultaneously over a single communication channel, where the channel is divided into several time slots and each signal is transmitted during its allocation time slots. So why do we use TDM? First, because the efficient use of bandwidth. TDM allows multiple signals to share the same transmission medium without overlapping in frequency. Second, because it is flexible. Various signals can be multiplexed onto the same channel and the allocation of time slots can be adjusted based on the specific needs of the communication system. Lastly, because it is cost-effective. The equipment required for TDM is less complex than other techniques, making it an economical choice for telecommunication applications.
Let's start with AM modulation. AM stands for amplitude modulation, which means that amplitude of carrier signal is changed with amplitude of informational signal. AM is simple and low cost, but it has low spectral efficiency and is proof to interference and noise. AM is commonly used in radio broadcasting. Next is FM modulation. FM stands for frequency modulation, which means that frequency of carrier signal is changed by the modulating signal. FM has high fidelity and high noise immunity, but it is more complex than AM. FM is widely applied in very high frequency and ultra high frequency radio broadcasting. Finally, we have PM modulation. PM stands for phase modulation, which means that the phase of carrier signal is changed by the modulating signal. PM has high spectral efficiency, but it is more complex than AM and is proof to phase noise. PM is used in digital communication system. To summarize, AM, FM, and PM modulation are three different ways of modulating a carrier signal with informational signal. Each type has its own characteristic and application.
Hi, I want to share what is bitrate and baud rate. Bitrate and baud rate are two terms often used in the context of digital communication, particularly in the field of telecommunication and computer networking. While they both describe rate of data transmission, but they are not the same thing. Firstly, bitrate. Bitrate, also known as data rate, is the number of bits transmitted or processed per unit of time. It is usually measured in bits per second or kilobits per second, megabit per second, or etc. Secondly, we have a baud rate. Baud rate, on the other hand, is the number of signal or symbol changes per second in a communication channel. Baud rate is often used in the context of serial communication, where each symbol might represent multiple bits. In the summary, the key difference is that bit rates directly measures the number of bits transmitted per unit of time, while baud rate measures the number of signal or symbol changes per unit of time.
We have three main types of digital modulation radio, which are amplitude shift keying, frequency shift keying, and phase shift keying. In simple saying, for ASK, the amplitude of carrier signal varies with respect to the amplitude of message signal. Next, for FSK, the frequency of carrier signal varies with respect to amplitude of message signal. Last but not least, for PSK, the carrier phase varies according to the amplitude of the message signal. In the next slides, I will briefly explain how it performs. This is ASK. We have input digital signal. After multiplied with the high frequency carrier signals, we get the output of ASK modulated signal. In ASK, when it is 1 at the message signal, it will have carrier signal at the output as shown here. And the output will be 0 when the message signal is at 0. And this is FSK. Carrier signal 1 is high frequency carrier signal, and carrier signal 2 is low frequency carrier signal. So we analyze this graph. Firstly, the signal is at logic 0. Therefore, the output signal will follow the pattern of this carrier signal too. And when the input signal is at logic 1, the output signal will follow the pattern of carrier signal 1. For PSK, from transition of 1 to 0, there will be a phase reversal of 180 degrees. Let us analyze this graph. At logic 1, the same carrier signal will be sent to the output signal. When the signal comes to logic 0, phase reversal happens. Then it continues until it reaches the next logic 1.
So now I will be explaining on the quadrature phase shift keying QPSK versus the quadrature amplitude modulation QAM. So for the QPSK, it usually changes in the phase, while at the QAM is changes in the amplitude and phase. So the QPSK is actually 2 BPSK system which has a 90-degree phase shift, while the QAM is a signal in which two carriers shifted in phase by 90 degrees, either in sine or cosine, are modulated and combined. So QPSK is better in noise immunity, while the QAM is low in noise immunity. QPSK is less complex than QAM, and normally QPSK is used for satellite transmission of MPEG2 video, cable modems, video conferencing, and cellular phone systems, while the QAM is widely used in cellular networks and backhaul, CATV networks, and fixed wireless access points and satellite transmission. Now I would like to discuss on the advancement in telecommunication, which is the open access network or RAN or advancement in 5G. So I would like to emphasize on the misconception and concern with the security and privacy concern. This is a risk of data interception and unauthorized access which worries about the safety of sensitive information transmission. The second will be the dependency and addiction, which the fear of over dependence on technology leading to addiction or social isolation. The third will be the reliability and downtime, which concern about the network outages, service disruption, and technical glitches affecting reliability. And last one will be the quality of communication, which the evolution of technology improving video and audio quality for more effective and long distance communication.
5G networks use higher frequency bands to transmit data at faster rates. Therefore, health concerns about 5G networks revolve around potential risks from increased electromagnetic radiation. However, established regulatory limits ensure safety. 5G technology is designed and deployed in accordance with established safety guidelines and regulatory limits. Ongoing research and transparent communication emphasize the commitment to addressing public concerns and maintaining the safety of 5G technology.
Let's discuss legal and privacy issue in the ORAN. For legal issue, ORAN introduced new security challenges for mobile network operators due to its multi-vendor environment and changes to threat surface area and technology interface. The Ensuring Security Framework Open Run Working Panel assesses this concern. Privacy concerns arise due to disaggregate nature of ORAN, making end-to-end security and privacy challenging. The use of open interface and standard protocol may introduce potential safety risk.
And what about the cultural impact of open radio access network? First, it increases access and connectivity because it contributes in expanding network coverage, especially in undeserved or remote areas. Second, local empowerment. It enables the use of equipment from various vendors, potentially allowing local business to participate. Last but not least, it allows cultural exchange through technology such as digital platform or social media.
In conclusion, Open Radio Access Network, or known as ORAN, represent a transformative approach to wireless communication infrastructure. ORAN revolutionized wireless network through open interfaces, fostering flexibility and innovation. It enabled cost-effective, interoperable components, accelerating 5G development and enhancing network performance. In essence, ORAN creates a more dynamic and efficient wireless ecosystem. Thank you from us.